In this example, we're going to find the area of triangle DJV. And if you did watch example 3, you'll notice, I'll bring that page back here for you, you'll notice that this is the same triangle, really. I mean, not exactly the same, but at least I should say that the side lengths are the same. These two triangles are congruent. So we used Hero's formula last and got 3 root 15. Whatever the units are, those would be squared. Let's try this a little bit differently. Let's see if we wind up with the same thing, utilizing... maybe we'll try to do one of those like 1/2 AB sine C formulas. So let's draw this thing. And there we are. So let's see, we've got, let's go D, J, and V. That's a D over there. And then this side will be 4, that's D. J will be 6, and then V will be 8. What we could do is we could use the law of cosines to figure out one of these angle measures. In this case, it doesn't really matter which one you find, but let's just try to find angle D here. So if we try to find angle D, we need to put the side opposite squared first. Then we'll do each one of the other sides squared minus 2 times each one of those sides, cosine of that angle D. Remember that this angle and the first one that you use to the left of the equal sign, those two have to agree, and then this side will be opposite of that angle. So if we simplify a little bit, we've got 64 here plus 36, and then we've got, let's see, looks like 16 times 6, or we could do 8 times 6, which is 48, and then double that. So that might be a little better. So double 48, I think that's 96. We can combine like terms here. So this will be 100. We definitely don't want to combine these two terms. They're not like terms. You couldn't do the 100 minus 96. There's a cosine D hanging out here and there's not one here. We'll subtract 100 from each side then. Negative 84 is equal to negative 96 cosine of D. Divide by 96, and we get the cosine of angle D to be 84 over 96. You could simplify that, but this isn't your final answer, so I think we'll just leave it. If we try to simplify and we make a mistake, then it'll throw the whole thing off. So why throw in an extra move in there when you don't have to? So we'll do the inverse cosine. Remember, when you're trying to find the angle, you'll do the inverse cosine divided by 96. And that'll give us 29.95, or if we round up here, that'll give us 29 degrees. So measure of angle D will be about 29 degrees. Now that we've got that, we can use our area formula with sine. So the area will be 1/2 of the two sides that form the angle. So that'll be times 8 and then times 6. And then the sine of the included angle there, 29 degrees. Let's see what our calculator says. And then we'll do sine of 29 here. And we've got about 11.6. So the area is approximately 11.6. And then, of course, whatever units those are squared. We're not given units in this problem, so we can either leave it blank here, or if you prefer, you could do the little u squared just to remind yourself that whatever units you're using, those will be squared. Now you might be thinking to yourself, Mr. Valsa, that is not the same thing we got before. So remember that these two triangles from example 3 here are congruent. We've got 11.6, and here we've got 3 root 15. Well, boys and girls, there is good news here, and the good news is that 3 root 15 is about 11.6. The reason why these are just a little bit off is because we rounded that 29 there. So anytime you round in an intermediate calculation, your answer will be off a little bit. When you round, you're going to be losing or gaining some value that wasn't there before. So if we use Hero's formula, we can provide the exact value and get a little bit more precision. But you can see here that using the other area formula, we can get pretty darn close as well. So there you have it. Examples 3 and 4, either way you cut it, about 11.6 units squared.